team of 7 teachers that we brought into the lab, we juggled 6 different projects. And all of these projects came about because of some need that either our students had or some needs that we noticed in current classrooms and that fit within our expertise, and then some need that we as a lab had. And so everybody in our group worked on this as a collaborative effort. But today what we're going to do is we're going to have some key members give a little bit of information about that project and then share with their perspective of coming into ISB to work on a project that then will extend beyond ISB. So as far as the format, because we have so much to kind of move through, is we're hoping to have there's going to be 6 kind of mini presentations. And then after each small presentation, if you have a few immediate questions, we can take those, but then we want to move on into the next topic. So then at the end of our 6 presentations, we can have time to discuss and get your feedback and answer your questions then. So, without further ado, we're going to bring, and I'm going to let each person introduce themselves and talk about their projects and their perspectives. So first we're going to bring up Danny and Aisha, 2 of our interns in the lab this summer.
Alright, hi everyone, I'm Aisha McKee. I go to the International School of Bellevue.
And I'm Danny Thompson, I go to Baliga High School.
And we are 2 of the 3 high school interns in the Baliga lab this year. So, to start off, I guess the reason we came here, at least personally my reason I came here, was to kind of learn a little bit about research science and what it means to be a research scientist. So, I know that Danny had a kind of a similar goal, and so what we decided to do was interview several people who worked in labs throughout ISB and who did a variety of different things, and kind of talk to them about their experiences with research science and just how they had gotten here and stuff like that. So we interviewed Bruce, Jared, Josh, and Monica, who work in 4 different labs throughout ISB. Bruce works with the microarray facility, which does all microarrays for ISB. Jared worked on the Family of 4 Genome Project. Josh works on mass spectrometry, and Monica works on the diatoms in our lab. And so they all have really diverse backgrounds and do completely different things here, but it was kind of interesting to see that they all kind of had some things that they said, but all of them kind of said in some way or another. And so we took those and kind of are taking them to heart now. And so what we can say about the interviews in terms of like all of them together, summarizing them would be the fact that they really stress the fact that you should be multidisciplinary. You should make sure that in your college experience and throughout your science career that you should definitely make sure you're multifaceted and work with a variety of sciences. So not just biology, but biology, chemistry, computer science, engineering, a little bit of everything, so that you yourself are more diverse and you can work with more problems than you would if you were just singular-minded. They also talked to us about making sure we broadened our scope, looking at other options within our undergrad years, and then later on, because we have time, especially in undergrad, you don't necessarily have that time when you're doing your graduate project or when you're getting your doctorate degree or anything. You just don't have that kind of time. So undergrad is especially a great time to look into other fields or other classes that you wouldn't necessarily have a chance to take otherwise. And then we thought kind of the most interesting thing out of the interviews that we got was the fact that these 4 individuals happened to come to ISB, and all through different ways, but they all have made it here and they all have a common goal of working with systems biology and spreading that kind of science throughout the community. So we thought that was really interesting. And then hopefully this afternoon we'll also be interviewing Lee Hood for a little bit, so it'll be another person to talk to. So then what Jenny and I actually did kind of on a more day-to-day basis was we worked on optimizing the environmental impact on gene networks module, which which our lab has almost finished at this point. Actually, I guess it has finished it. So it has 4 lessons, and of those lessons, we've kind of aligned them with state standards, and they've been edited, and there's answer keys, and they're ready for classroom use and for teachers to just take them and use them. And so the reason we have the project has gone on for the last several years is it's actually been a little bit unnecessary in a way almost. The whole module was basically designed about 2 years ago, and we had a slight setback in the fact that most classrooms don't have incubators and most districts don't have incubators. So the fact that our module was written for an incubator was kind of really hard for most classrooms to use. So Danny and I actually worked on a way to kind of get around that, and the fact that you could use stir plates and flasks, and they kind of got the same results without most of the cost of an incubator. So that's what we've been working on. And so then Mary, who is not with us today, but was one of the teachers that we also worked with, had some things that she wanted to say, because she was one of the ones that worked on the final touches to this module. And so one of her things was the fact that systems biology is almost like a lifestyle. It's very integrated into your system, and everyone, she was talking about how she had dreams about how she was going to integrate this into her classroom because it was just so innovative and it works really well, and the things she learned here she can apply in her classroom. And that kind of leads to the next point, but the fact that this is her 30th year teaching, and this kind of learning and this kind of biology and science is stuff that she can apply in her classroom that will really keep her energized and stimulated throughout these next couple of years that she'll be teaching. And her main point, which she always was talking about, was the fact that you need to teach it to someone else. And that's kind of what we're doing now, is we're teaching what we've been doing to you guys so that you can see what we've been working on throughout our time here over the summer. And then she also was really happy with the fact that ISB has things like discussion groups and research in progress talks and other seminars and whatnot. And that really helps individuals within ISB learn and also teach what they've been working on, which she really liked. And just wanted to make sure to thank everyone. She hopefully will be here next summer, I think. So.
Alright, so this module that we worked on, it was designed to allow students the opportunity to design their own experiment and also learn how the environment can impact gene expression. And Halo bacteria, the organism we work with, is a great model organism for this because depending on the amount of light and oxygen in its environment, it alters production of bacteria or rhodopsin, which is a protein, the purplish pigment, and you can visually see in that cell pellet this protein that's in the cells. So it's pretty easy for students to see the impact of changing the environment just by looking at the pellet from the cell. And what we did was we worked to optimize the procedure for this lab so that they could see the difference more easily. The first thing we did is we made that cardboard holder for flasks, because flasks they're great for the classroom, but when without the holder they would either congregate in the middle of the stir plate or fall off, and that kind of ruins the experiment. So we had to make this cardboard holder, and it's really cheap and easy to make for teachers, which is really important. In earlier experiments, we used the aluminum foil to simulate a dark environment, and that didn't work very well. So we experimented with black electrical tape, and that seemed to work a lot better. We're not totally sure why, but we found that in other work for this lab, the ocean acidification work, they found that aluminum foil is permeable to CO2, so it's possible that it was letting a little bit of light through also. There's also another issue that any light that did get in was reflected around inside by the foil. Black electrical tape seems to work a lot better. And we also experimented with proportions of CO and halo and distance from the light. So theoretically, in a highlight environment, halo would produce a lot of bacterial rhodopsin, which would turn the cell pellet pretty deep purple. In low light, it wouldn't produce any or hardly any, and the pellet would be tan or almost clear. So that's what we were trying to achieve. We didn't quite get there, but you can still see that there's a difference in the highlight and low light, and that's really important for the students to be able to see that there's a difference based on changing the environment. So, and in our first trials, we weren't really able to get a difference at all, so it was kind of a success. A big thing that we gained from doing this work was a much better understanding of the real scientific on to something else, just because of the time constraint, you can't really go back and try again. But that's not really how real science works. You keep going back and changing your experiment, maybe altering your question, doing slightly different things. But that's just not really possible in high school. So this module kind of helps to teach that. And it was also a pretty informational experience for us. We learned a lot about how kind of real science works. And that was one of my main goals, and I think we're really anxious too, is to learn what it was like to be a scientist, a real scientist, for our internship. So doing this was really helpful for us. And another thing we learned was to use computers a whole lot more than either of us would have expected. But we actually both enjoyed doing that quite a bit. So we thought it was a great internship and learned a lot. So another part of our internship was making this website. It's kind of like a culminating project of all of our work. And these are the last 7 years of websites. And this is kind of an overview of our website. We talked about most of the stuff we did, give an overview of all our labs. We also got to some pretty interesting technology, so we talked about that a little bit. We also have some stuff about us. And there's a lot of other content you can check out if you want to look at the website. It'll probably be up by tomorrow. So now I'd like to bring up Lexi. Oh, any questions?
For a moment, in the scientific workflow slide, at some point you get after experiments, the hypothesis is true or false. You probably want to change that to consistent